Hello and welcome to another week. I have a new computer now, and therefore you get to see actual video of my face, I guess, whether you want it or not. First off, I'm just going to say I miss being in the classroom with all of you guys, but we're going to make the best out of what we've got right now. Yes, my office is very poorly lit. There is some furniture behind me that typically isn't, but after we had our squirrel roommates in the ceiling, some furniture got moved around. So, we could set up a ladder and climb into the attic, and also had to move stuff out of the room where the squirrel had clawed through the ceiling. Anyhow, I hope everybody is doing well. And maybe next week you'll see a different view behind me, much more clear. This week we're finishing up our atomic theory. And you're going to get to do sort of a crafty project. This should be pretty brief today. And remember, everything is meant to take a maximum of 2.5 hours in the week. So if you're finding it's taking longer than that, just let me know. Okay? I don't want anybody spending more time than that. Without any further ado, here's your last little bit of info on atomic theory. All right, so let's get started on week 4. It's kind of strange to see week 4 up there because in certain ways it feels like way longer, and in certain ways it feels like way less time. So we're just finishing up with atomic theory today. It should be fairly brief, and it's kind of like the most important thing to take away. So if you leave our chemistry unit remembering one thing, today's stuff is what to remember. And yeah, let's move on. So we've got our key concepts. You'll notice this is very differently set up because I have a different computer here. An atom is made up of electrons, neutrons, and protons. That is huge. Knowing what we call subatomic particles are and which ones make up an atom. And then that the atomic theory continues to develop. So what you're learning today is not the be-all, end-all of atomic theory. There's way more, and I would say I know just enough to know that I don't know that much when we look at atomic theory as a whole. Okay, so I have an activity that you can try, and I want you to see, can you cut a piece of paper down to the size of an atom? So atoms vary in size, but a mid-sized atom is about 0.0000002 centimeters long. So yeah, super huge. So you take a strip of paper. I want you to predict how many times you would have to cut the strip in half to get it to a piece that is about 0.0000002 centimeters wide. I may have said too many zeros. And start cutting. So you're just gonna cut the strip in half, and then what you're left with, you're gonna cut in half, and then one of the halves you're left with, you'll cut in half, cut in half, cut in half, cut in half. Okay, let's take a pause. Well, I hope you didn't think I was gonna make you do this activity alone. I got my paper, I got my scissors. Time to start cutting paper. So I'm just gonna cut in half. So there's my first cut. And I'm going to take a half piece, cut that in half. That's cut 2, already significantly smaller. Cut 3. Cut 4. 5. 6. 7. 8. Getting much smaller. 9. Where we're at right now. 10. Pretty small now. At 11, we're left with a piece that almost just fell on the floor, and I might not have been able to find it. 11 cuts. Twelve cuts. And I don't know if I can even do this with just scissors anymore. Well, I think I just lost my piece. 13. And now I don't have the proper tools, but I'm very far from the size of an atom. They're tiny. So, how many times were you able to cut your paper in half? Probably several times, but eventually you're running out of space to cut in half. And how many more times would you have to cut to get your paper to the size of an atom? Probably a lot more. We don't even have a notch on our rulers that shows that. Okay. So the atom. The atom is the smallest particle of an element that retains the properties of that element. So when we're talking about elements, we're thinking things like carbon, oxygen, nitrogen, helium, neon. Okay, you're going to learn a lot more about different elements in grade 9, but the atom is just the smallest piece of an element that still has the same properties. And we're thinking about those properties that we were looking at when we talked about chemical and physical properties, their reactivities, their density, that sort of thing. And all matter is made up of atoms, and atoms are made up of smaller particles called subatomic particles. So that sub portion means that it's less than an atom. All right, so here is our basic setup. In the center, we have a nucleus. So it's this tiny region at the center of the atom. And inside the atom, we have two subatomic particles, protons and neutrons. And the number of protons in the nucleus determines the charge of the nucleus and the identity of an atom. So however many protons there are tells us what element it is. So basically every element that you're going to look at, well, this is not even basically, every element that you'll look at has a different number of protons in its nucleus. Outside of the nucleus, we have these energy shells. And that was something that Bohr was talking about when we looked at atomic theory last week. So the energy shell accounts for well over 99.99% of the volume of the atom. So in actuality, this would be much more spread out. We tend not to see the actual spread of the electrons in those shells in diagrams, just for saving space. And electrons occupy specific energy shells. And there's a spread out cloud of negative charge that exists in the whole region, all at once. So we mentioned that the protons are positive, the electrons are negative. So here's a little bit about electric charge. Protons have a positive charge, electrons have a negative charge, and neutrons, they're neutral. They have no charge. So atoms have equal numbers of protons and electrons, and so overall an atom is uncharged or neutral. So you're going to be making some models of atoms, and a key thing to make sure is that you have the same number of protons as you do electrons. So you may have gotten this from when we were cutting up paper, but atoms are incredibly small. So if an apple let's magnify it to the size of the Earth. The atoms in that apple would be the size of the original apple. They're incredibly, incredibly, incredibly small. So a lot of our modeling is just that, it's a model. We can't fully confirm that everything is necessarily exact at the moment. There's something called the nuclear force. With it being nuclear, that has to do with a nucleus. So in the future, you'll learn about things like nuclear energy. It all has to do with the nucleus of an atom. So the nuclear force, it's what holds protons and neutrons together. So that's basically all you need to know, that protons and neutrons are held in that nucleus by something called the nuclear force. Okay. And just to finish up here with this information today, here's our subatomic particles and just a little bit of information about them. So here's our proton. It has a +1 electric charge, and its relative mass is 1,836. So we don't say grams or anything like that. We use something called an atomic mass unit just because their mass is so small that it's easier to make up a different unit. And protons are in the nucleus. We also have our neutrons. They're neutral, so they have no charge, so their charge is 0. And their relative mass is 1,837. So very similar to the proton. So we usually basically say they're the same size. And they are also in the nucleus. Then we have the electron, which has a -1 charge, and its relative mass is 1. So what you can see when you're comparing these masses is that the electron is far smaller than the proton or the neutron. So what that means is when you are creating your projects this week, you'll need to show the electrons being smaller than the protons and the neutrons. And our electrons are surrounding the nucleus in those energy shells. I will be back with video about your assignment. All right, welcome back to more of my face than you've seen in 2 months. For your project this week, you're going to be making your own atomic model. So in your assignment sheet, it tells you which atoms you can create. Mainly the idea is I didn't want you doing something that went too far beyond what we've been looking at this year in science. And I will be giving you the number of protons, neutrons, and electrons that need to be in the diagram. The idea is you are using whatever you have around you. So it could be a cake because everybody in your house is just baking a lot, or brownies or something that you've decorated. That's totally fine. One thing that I thought of, because I live in a household where we pick up a flat of Coke Zero every time we're at Costco, is that you could use different pop cans for the different subatomic particles, or just like cover the tops with different colors, something like that. I even made one, and it's not impressive, but basically I thought, well, I have all these cardboard boxes because I just bought a computer. And I thought I would use cardboard, use some of my nail polishes that I didn't really care for to change their colors. And my original idea was that I was going to sew things together or crochet them together, which very quickly seemed like not a great idea. Then I was going to glue gun things into an orb, but I didn't have anything to glue them around, so it was just going to fall apart. So in the interest of also making sure this wouldn't take excessive amounts of time, I did this. So this is my model of neon. It's a a little difficult to see, but I have my protons and neutrons in the center there. My protons are blue. My neutrons are a greeny blue. Unfortunately, it didn't come out very clearly for the video. And then I have my smaller rose gold electrons around the edges. Because I felt like I should make it 3D instead of neatly drawing nice circles for the energy shells, I glue gunned yarn. It means this is a big old mess of glue. And I just put down here that is neon. So I'm hoping after looking at this project seems very achievable. Basically, I cut circles. I used lip balm as my stencil to cut little circles out for the protons and neutrons. And then I used a highlighter as my stencil for my electrons. Now, key thing is you're going to have two shells, two energy shells for your diagram. It's guaranteed for all of you. It's part of why I chose what I chose. Your first two, you're all going to have two in that first shell, and then whatever is left over is going to be in the second shell. So because I chose neon and it has 10 electrons, I put 1, 2 in my center shell, and then I went 1, 2, 3, 4, 5, 6, 7, 8, and put those in my second shell. Okay, so this is your, everything's mirrored, so I'm a little confused. This is your beautiful exemplar. I do feel like many of you can do a better job than this. I got very fixated on putting glitter on all of these subatomic particles, so you can't even see the glitter. So don't just focus on glitter. Maybe that's my big suggestion. You can even see just how upcycled this is. So have fun. Try to do, if you're crafting regularly, or like I said, you're baking regularly, tie something into that. Take a picture, send it along. If you've got, if you're like me and you got lots of yarn, you got lots of cardboard, you can do something beautiful like this. You have some options, but I don't want you to have to go out and buy anything. Try to use what you got, okay? Have fun.